Hello, folks, and welcome to Couchbase Connect 2021. My name's Ian McCloy, and I'm a Principal Product Manager here at Couchbase. I focus on the area of security for both our on-premise products and our cloud environments. Today, I'm going to talk about 10 critical components to mastering Couchbase Server security. This is to help administrators configure Couchbase to be as secure as possible. So I'm going to go through some of those features and functionalities that we have in Couchbase Server in order to ensure that your cluster is secure and has the highest level of security available. So those different areas we're going to look at today are encryption at rest, secrets management, encryption in transit, network defenses, auditing, password policy, administrator access, application access, authorization, and then maintenance. So the first area we're going to look at is going to be encryption at rest. And so the areas we're going to look at are in the order that you would normally apply those into your cluster. So normally you would deploy the encryption at rest technology first before actually installing Couchbase. So encryption at rest is a technology where you want to ensure that any data that you write into your Couchbase database is encrypted before it gets stored into the storage system. And why is that important? So you might be recording medical data or financial data, and then imagine sometime later you decide you want to replace your Couchbase servers with more performant servers, or you want to reprovision a server for another use case. You want to ensure that the data that was in the database, such as those confidential documents, aren't readable by the next use case or whatever the storage gets used for in the future. This is also really important for cloud provisioned instances. So imagine you provisioned on AWS or Google Cloud, and you wrote a bunch of confidential information on the disk. You want to ensure the next person that has that same storage volume in the future can't read that confidential information. So this is why it's an important aspect in a lot of different compliance regulations. Also, our technology, we have a field level encryption technology where you can actually encrypt specific fields inside of a document inside the SDK at the application layer. So this is, imagine you had a user profile document, and inside that document, you had a credit card information or a social security number. You could encrypt just that one field without encrypting the entire document. And this, as I said, is done in the client side. So when it enters into Couchbase Server instead of the cluster, it remains encrypted. It never is unencrypted at any point. And when it gets written to disk, it's fully encrypted. So that's another way to actually get at-rest encryption into a Couchbase Server cluster. So there's a few different technologies that you can use when you do implement it at the system level. So we've certified LUKS encryption on Linux, or there's FileVault or BitLocker on Windows and Mac environments. Or as I mentioned, in the cloud environment, you might use something like an encrypted EBS volume. So the next area we're going to look at is secrets management. So Couchbase Server actually has a built-in secrets vault that it's used to encrypt any sort of cluster-wide secrets that you don't want to be written to disk in an unencrypted format. Similar to encryption at rest we saw on the previous slide, this is to do with just specifically for secrets within the cluster. And so the vault that is encrypted uses industry standard high-grade encryption using AES-256 algorithm in GCM mode. And how this works is an administrator puts in a master password, and then this uses a PBKDF2 to generate a key which never gets persisted to disk. Then that generates an encryption key, and that's used to encrypt and decrypt the secrets vault. The secrets management is always enabled on a cluster, but by default, it has a null master password. So it's really important to go in and change that master password so that you can completely and securely encrypt the secrets in a cluster. Some of those secrets include things like S3 backup storage credentials or credentials for a cross data center replication for another cluster. So this is an important one to make sure you implement. The next area we're going to look at is encryption in transit. So encryption in transit is making sure that any of the data that goes over the network is fully encrypted and secure, so it can't be intercepted by attackers or people who are looking on your network. And with Couchbase Server, we have a setting that's different encryption settings. One of those is strict. With a strict encryption level, this enforces network encryption using TLS. And so this ensures that no traffic in or out of the Couchbase Server nodes is done in plain text. It only allows encrypted network connections. So those connections can be between Couchbase Server nodes, from node 1 to node 2, for example, or from an application to the Couchbase Server cluster, or for an external system such as an LDAP authentication system. You want to always have that network traffic encrypted at all times. Couchbase Server supports TLS version 1.3, and by default, the minimum level of TLS that's allowed is version 1.2. Anything older, such as 1.0 and 1.1, are not considered secure, so you should not use those. The next area we're going to look at is network defenses. So network defenses is basically looking at how you protect the network, not just with the encryption, but making sure that you're blocking connections and making sure that you're not allowing connections where they're not needed. So Couchbase Server, we support both IPv4 and IPv6 address families, but maybe in your cluster, you don't use IPv6, you're only using IPv4. You can implement a configuration setting that only allows IPv4 connections. That means you don't need to worry about building in firewall rules or restrictions around IPv6 connections. Or maybe the other way around, you're only using IPv6, you would do the same for IPv4 and only allow that one address family. It's really important to look at not only a perimeter level firewall, but also a per node firewall. And that's what you see in this diagram. So each node should have a firewall only allowing the ports for the services that are in use, blocking all the network ports for services you're not using, and blocking all the ports for unencrypted or insecure network connections as well. It's also really important to note that you shouldn't put Couchbase Server directly on the internet without a firewall. So that's why you see this sort of multi-layered structure of firewalls around your cluster, as well as firewalls on each individual node. The next area we're looking at is auditing. So auditing is really important to make sure that you're seeing events that happen on the cluster and you can respond to them. So there's a built-in audit system in Couchbase Server that creates audit events in a standard JSON format. Typically, our customers will take those audit events and import them into a security information and event management system, also known as a SEM. The SEM can monitor for unusual activity or events, such as failed logins or someone trying to break into your system. You can see those events and take actions immediately. It's also useful for forensic analysis after a break-in happens or some other unexpected event later on. So auditing is really important, and it's a built-in feature in Couchbase Server. The next area to look at is password policy. So the default password policy in Couchbase Server it's quite weak. It only requires 6 characters. This really should be changed to a higher standard. So the best policy for this is either requiring users to have a 15-character passphrase, so that's multiple words separated by a special character, or a very strong password. And so that's at least 12 characters, but has to be uppercase, lowercase, numbers, and special characters. So you can see 2 different examples on the diagram. The next area to look at is administrator access. So the best practice for administrators is to actually use external authentication. And when you use that external authentication, you should require that administrators use multi-factor authentication. Multi-factor authentication is incredibly important. It increases the security of those accounts exponentially. Lots of research has shown that accounts that use multi-factor authentication are only as likely as 0.01% to be compromised as using just passwords alone. So it's really important, and that's the best practice. Use external authentication, such as LDAP, and require administrators to use multi-factor authentication. And then application access. So application access is machine-to-machine connections, basically. For the best practice here is to use our feature, which is X.509 certificates for authentication. And this lets you do something called mutual TLS. This means that the application knows who the server cluster is and trusts it, and the cluster also knows who the application is and trusts it. So there's a bidirectional certification and trust of the connection. Basically, how this works is the certificate file is like a really long password, hundreds of characters long. And that means it's very resistant to brute force attacks or dictionary attacks. And it's essentially like a very strong password policy, that much stronger than you would normally put into a password policy. And that's why it's so strong and is the best practice. And it also, as that mutual TLS, provides additional security enhancements above and beyond just the strength of the password. The next area to look at is authorization. So authorization is basically role-based access control in Couchbase Server. So you should assign roles to individuals or groups, but only assign the minimum amount of roles that those users actually need. And this is called following the principle of least privilege. Each user should have their own account, each application should have its own account, and you should only apply the roles that are absolutely necessary. And the last area that we're looking at is maintenance. So there's tasks that you need to do on a regular occurrence, making sure that your entire cluster remains in a secure environment. So number one thing is to look at our alerts page, couchbase.com/alerts. This is where we'll provide information about any new security vulnerabilities that we've published, or data integrity issues, that sort of thing. And when you see those, we'll provide instructions on either how to work around them or the version that you need to upgrade to in order to resolve that security issue. There's other concerns, such as making sure that you rotate your keys on a regular basis, such as the master password we looked at earlier. And then the other area to look at is certificate expiry. You want to make sure that you understand when the certificates are expiring and address those before they expire, and making sure that your cluster remains without any interruptions. So in summary, that wraps up 10 critical components to mastering Couchbase Server security. As you can see, we've got lots of great security features and really simple steps to ensuring that your cluster is as secure as possible. Thank you very much for your time. I appreciate it.